Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the series of inequalities. We are in lecture number 4 and in previous lectures we have discussed a lot of things. So you have to go through the previous lectures before you watch this lecture. In this particular lecture we are going to talk about the inequalities where you have variable in denominator. Yes, that matters a lot. So let's see how do we deal with the inequalities having variable in the denominators. So let's come to the blackboard and start solving some questions. Well, so here we have, I have a question for you. This is x minus 2 by x plus 3 greater than 0. So how do you solve this inequality? How do you solve this? Well, what is the difference? What is the difference if I have variable in the denominators? How does it affect? Understand this. Do you remember we have discussed in the first lecture of inequalities that if you multiply by negative number, the sign of inequality changes. If you multiply by negative number, the sign of inequality changes. Otherwise, the sign of inequality changes. Yeah. Yes, so if you have variable in denominator, let's say 1 upon x, that's greater than 1, for example. Okay, in that case, what should be the possible values of x? Now think about it. If I multiply x here to this side, like this is what we do generally in case of equation. Suppose if I have 1 upon x equal to 1, then what do? We multiply x this side, so this become x 1 equal to x, isn't it? Now if I do the same way here in inequality, then it will be 1 upon x, or rather 1, and if I multiply here 1 and then x is here. Now can you be very sure that here the sign between them is not going to change? I mean to say, when you multiply here, are you sure that this x is positive? X is a variable, right? And it could be positive as well as negative. Yeah. So we don't know that, and that's what affects when you have variable in denominator in inequality. So you have to be sure whether the denominator is positive or negative. So how do we deal with such kind of situation? That's what we are going to discuss in this particular lecture. Are you clear about it? Are you clear about the question? The question is, if you multiply x to the right hand side, should we change the sign of inequality or not? Why that's the question? Because do we know whether x is positive or it's a negative value? If it is negative, then sign of inequality should change, and if it is positive, then it should remain the same. Yeah, so we are not sure about it, right? So how do we deal with such question? Okay, if you want to solve the same question, let's say, let's complete this part. So what do we say that, okay, here if I take 1 upon x greater than 1. Now to solve this, as we discussed, that we should be aware about the property of x, whether it is positive or negative, before we multiply to the other side. Before we multiply it to the other side. Now I want to multiply this to the other side considering x to be positive, more than 0, right? In that case, okay, so this is case 1. This is case 1. In that case, if I multiplied x to the other side, the sign of inequality should not change, it should remain the same. Yeah, so it will be 1 greater than x. Yeah, so think about it. X is greater than 1, and because of this we got x less than 1. You know what? In this case, we have to combine this both condition. So we should use the conjunction as AND. Yeah. So here we are trying to say that this is possible. 1 upon x will be greater than 1. It is possible when x is more than 0 but less than 1. Did you get it? I combined these two conditions. I am getting x is less than 1 only because when we said x is more than 0. I am getting the condition of x is less than 1 only because when I get x more than 0, right? So we combine and say, okay, this is the conclusion, but this is one side of the story. If I look at the other side, which is the next case, the case 2. Case 2. Here we say, let x be a negative value. That means less than 0, negative value. In that case, if I multiply x to the other side, it will become 1 x, and the sign of inequality here, which was given in the question, will get reversed. So will be reversed. So here, instead of the greater sign, the greater than sign, I am going to get the smaller sign. Are you getting it? Yeah. So what conclusion do we get? We get the conclusion that x is less than 0. Do you want to see on the number line? X is less than 0, but here we are getting x more than 1. Yeah. Now, do you get any common solution? Do you get any common solution in this case? When you consider this, do you get any common solution here? No, you don't get any common solution. So here we will say this case, the case 2 is not applicable because we are not getting any common solution here. So the only solution possible for this inequality is here in the first case. So this is the only solution possible. So this will be your answer. Yes. So I hope you understood that it matters. If you have got variable in denominator, then it matters. Yeah. So how do we solve? Let's solve some more questions and understand. Yes, let's solve some more questions and understand this. Fine. So here we got x. All right. We take this down. So if we have this x minus 2 by x plus 3 greater than 0, then how do we solve this? So now we have this value which is greater than 0. Greater than 0 means what? This side should be positive. Yeah, all the positive numbers are more than 0, correct? Now this fraction, let's say p upon q, this fraction is possible to be more than 0 in case, in which possible cases? There are two cases. Case 1, okay, change the color. Case 1, okay, case 1, when p is also positive and q is also positive. So positive by positive will be a positive value, right? Then what next? The other condition would be you got p upon q and p is negative and q is also negative. So you can see negative and negative will be cancelled. So you will get a positive value, isn't it? Yeah. So we are going to solve this out. Okay. So I hope you understood that which are the two cases we are going to discuss here. Yes. So if both are positive, that's the case number 1. Yeah. If both are positive, then how do we solve this? If both are positive, then how do we solve this? If both are positive, then we will say the numerator, which is p, which is x minus 2, that is positive, and it's not or. Okay, this conjunction is very important. Yeah, you can't say or. This has to be positive as well as x plus 3 should also be positive. In that case, what you have? X is more than 2 and x is more than minus 3 as well. Yeah, both are positive. So do you want to see on the number line how does it look like? Do you want to see on the number line how does it look like? This first case, it will look like this. Let me draw the number line for you. 0, 1, 2, here minus 1, minus 2, minus 3. So more than minus 3 as well as more than plus 2. Yeah, as well as conjunction. Understand the conjunction and. Whenever we have this and as the conjunction between two inequalities, in that case we always go for the common solution. So the common solution will be more than 2. So what is the conclusion here of case number 1? Conclusion is x is more than 2. Did you understand this? Did you understand? Similarly, if you go for both numerator and denominator, both are negative, so negative negative cancel and the fraction will still be more than 0 as per the question. In that case, we will say the numerator, which is x minus 2, is less than 0, and the denominator, which is x plus 3, is also less than 0. If x plus 2 is more than x minus 2 is more than 0, in that case we get x is less than 2, and here we'll get x is less than minus 3. Yeah, and now I hope you know what is going to happen. We have the number line, we got 0, we got 1, we got 2 here, we got minus 1, we got minus 2, we got minus 3 here. Yes, less than minus 3 and less than 2. So the common solution here will be, if you are able to identify this without drawing the number line, that will be a really favorable condition. Yeah, condition for you, because you don't have to waste time. Well, so here you got final conclusion as x is less than minus 3. X is less than minus 3. That's the final conclusion, right? So this also works. That means from the first case you got x more than 2, second case you got x is less than 3. Now between these two conditions, what should be the conjunction between case number 2 and case number 1? What should be the conjunction? And, or, which one? Yes, we should use or, because either both are positive or both are negative. Yeah, you can't say both are positive and both are negative. It doesn't make sense. Yes, so between these two conditions we should have the conjunction or. So what is the final answer? We'll say the answer is x is less than minus 3 or x is more than 2. Yeah, do you want to write this in form of the range, the bracket? Yes, we have discussed this multiple times. So yes, try to write this in the form of sets. X belongs to minus 3 and then less. So less, it will go up till what? Minus infinite. So minus infinite to minus 3. None of them are equal to x. So, you know, for both it will be open bracket. Union, for or we use union from 2 to plus infinite. Okay. So either you can find this in the options or this in the option. Both of them are correct. Yeah. Question number 2. Here again we have the same situation where we have got variable in the denominator. So what do I have? X plus 4 by x minus 1, but this time we have a number to the other side, that's 3. So in such case, what do we do first? We take this number, basically all the terms, number, variable, whatever it is, to one side of this inequality. So here we get x plus 4 by x minus 1 minus 3 greater than 0. Simplify this, simplify quickly. You got x minus 1, x plus 4 minus. You know how to simplify this part? I'm sure you know that, right? Greater than 0. Simplify further, you have x plus 4 minus 3x plus 3. If you can skip any steps in this, please do that. Save time. I have to write all the steps because I am explaining this to you. Otherwise, you should do it in the lesser, do it in as minimum as possible steps. X minus 3x will be minus 2x here, and 4 plus 3 will be plus 7 here, greater than 0. Now greater than 0 means positive. So again, the positive, you will have two cases in this case. Which are two cases? You know, after this step, you can also do it in one more way, that you can multiply both sides by minus sign. and change the sign of inequality so that this 2x will become positive if you want to. Otherwise, even if you don't do it, the answer, you will get the same answer. Yeah. So let's say we got two cases here. This fraction is more than 0, positive. That is possible when this p by q fraction both are positive or both are negative, right? In that case, you will get the fraction as positive number, as a positive fraction. Yes. Now, if both are positive, it means minus 2x plus 7, this is positive. Yeah. So that way you get what? Let me simplify this. You get here 2x and 2 here in the denominator. So x is less than 7 by 2 and the denominator positive, that is x minus 1 more than 0. So you get what? X more than 1. Yeah. So you have these two. So 7 by 2 means what? 3.5 and greater than 1. So x is less than 3.5 and more than 1. This is the outcome you get from the first condition, which is both numerator and denominator both are positive. So do you have any common between them? Common values between them? 3.5 and 1? Yes. Answer is yes. We have that. You have to see on the number line 0, 1, 2, 3, 4. Here you have this 7 by 2, which is 3.5. This is where you got 1. Question said x has to be more than 1 and less than 3.5. So here the common part is here. Yeah. Do you remember? Do you understand why are we looking for the common values between them? Because we have the conjunction and. Wherever you have and, you look for the common solution. Yeah. The common values which satisfy both conditions. So here you got the conclusion of the first case is x more than 1 and less than 7 by 2. Fine. Similarly, if you try the second condition, the second case, what is the second case? Negative, negative. In that case, you get minus 2x plus 7 more than 0 and x minus 1. Sorry, not more than 0, negative, right? Less than 0, it has to be less than 0. My bad, I'm sorry. Negative, less than 0. Yes, if you simplify this, tell me one thing, go with shorter route. You have just changed the sign here. Instead of more than 0, in the first case, now you got less than 0 here, right? So everything will be reversed. So you don't have to solve this again. Understand? So you got same expressions. If you solve this, you are going to get the same answer. But because here you have the inequality sign which is reversed, you are going to get the reverse outcome, which is what? It has to be more than 7 by 2 and less than 1. That's what you're going to get if you simplify this. Don't believe me? Try this out. Okay, look at this. If I solve this first one, I'll take 2x to the other side. So you get 2x which is more than 7, and then if you take 2 down here in the denominator, so x is more than 7 by 2. If you simplify 1 this side, so this will get you x less than 1. Yeah. So you can understand from here also, looking at the number line. For first case, if you are getting this way, x is more than 1 and less than 7 by 2. For the second case, where the sign, you are changing the sign of inequality, the arrow will be reversed. Okay. So this is, you need to apply common sense, right? As I said, there is no point on writing all the steps. Do you agree with me here? Are you understanding? if the sign instead of greater than here, instead of greater than we got less than, instead of greater than we got less than here, that means when the arrows was this side, here more than 1 and less than 7.2, 7 by 2, then by changing the inequality sign it has to be more than 7 by 2 and less than 1. Did you understand that? Yeah. If not, then you have this way to solve and then draw it. But trust me, try skipping steps as much as possible so that you get the answer faster. Well, the conjunction between them, these two conditions are AND. So do you see any common values, the overlapping of these two lines? No. So here we will say this solution, this case will not be applicable, right? So you got the answer. Answer is what you got from the first case. This is your answer. Did you understand? Yeah. So what happens if you have a number? What happens when you have a number here greater than 3? You take the number, or even if instead of number you have got variable, any other expression, take them all to one side and then simplify and get a simplified fraction, and then you see whether it is more than 0 or less than 0. Let's see one more question. We'll keep on solving question by question. I might not be able to solve a lot of questions in one video, but I will keep on bringing new videos, new lectures to you to practice questions, because maths, quant is all about practicing different types of questions. Well, here you have this, let me write it again for you, 2x minus 5 by x less than 2. So what do you see here? 2. What are you going to do? You will take it to one side of the inequality. When do we have to do this? When you got variable in denominator. You see variable in denominator. In that case, we have to make sure the other side should be only 0, nothing else. Okay, so simplify. 2x minus 5 by x minus 2 less than 0. 2 by 1. How do you simplify the fraction? Come on, how do you simplify the fraction? Denominator will be x, because x into 1 is x. X multiply here, 1 multiply here. You get 2x minus 5 as it is, because there won't be any change if you multiply by 1. X multiply here, it's going to be minus 2x less than 0. Now what you do? Oh, 2x minus 2x is 0. So you got only minus 5 by x, that is less than 0. This has to be less than 0. So you got only denominator. See, minus 5 is already there. Minus 5, which is numerator, is already there as a constant. So in this case, you are not going to take two cases. You are not going to get two cases of p by q and p by q. Can you tell me why? Think about it. Because here numerator is already a constant value, minus 5. Only denominator is variable. So you can only say denominator is positive or denominator is negative. Numerator is constant, right? Minus 5. So with minus 5, numerator to be minus 5, which is a negative value. So here this will be negative in both cases. Now here you want this left hand side to be less than 0. Less than 0 means negative. Now negative upon negative will make it positive, isn't it? So here we are not looking for positive. Here we are not looking for more than 0. We are looking for less than 0. Are you getting me? In that case, this will not be applicable. Not applicable. So you have only this part. Now what do you do next? What do you do next? Come on, what do you do next? In that case, we will just say that for any value of x which is more than 0, positive, look at this, positive. Denominator is only x, there is no other expression but only x. So if denominator is positive, that means x is positive. In that case, for any value of x which is positive value, for any positive value of x, this fraction is always going to get you a negative number. Why? Because numerator is a constant negative, -5. Are you getting this? Yes. So what is your answer? This is your answer. Here you go. This is your answer. Yeah, clear? Okay. Let's try one more question. One more question. Come on. I know this video is getting little longer. This lecture is getting little longer, but I hope that it's giving you some information, important information, right? Okay. Before taking positive negative, first we'll simplify this fraction because we got 3 to the other side. I will take it to all at one side, the other side is only 0. Simplify this here. Yes, simplify this here. How do you simplify? Multiply, 1 multiply here, this multiply here. What do you get? 2x minus 1, here x plus 2 minus 3x plus 2 less than 0. Simplify further. 2x minus 1 minus 3x minus 6 by x plus 2 less than 0. Simplify. 2x minus 3x will be minus x. Minus 1 minus 6 is minus 7. Here you got x plus 2. What is that? It's a less than 0. Less than 0 means negative. Less than 0 means negative. Yeah, negative means what? So you want this entire fraction to be negative. Now, what combinations are possible to have this fraction to be negative? Yeah, fraction to be negative, p upon q to be negative. That's possible when if numerator is positive, then denominator is negative. If numerator is negative, then denominator has to be positive, right? I mean, if you take negative by negative, it's going to get you what? Positive. Are you getting it? Now, that's your first case. This is your second case. For first case, let me simplify this further. First case, for numerator to be positive, what do I do? Minus x minus 7 more than 0, which gets you what? Okay, before that, let me write this for you. Conjunction is and. If numerator is positive, then denominator has to be negative. So it's and. So here negative means what? You got x plus 2. So x plus 2 negative less than 0. This will get you. Let me take x the other side to make it positive. So x is less than minus 7. And here x is less than minus 2. So what will be the common range for x less than minus 7 and x less than minus 2? Yes, minus 1, minus 2, and somewhere here you will get minus 7 also. So less than minus 7, less than minus 2. The common range will be x less than minus 7. Are you getting it? Yeah, if you are following all my lectures, I am sure this must be easy, and do not skip any part of the video, otherwise it will be confusing to you. Yes, so here x is less than minus 1. This is what you get as the conclusion. Similarly, if you do the other side, do you want me to solve that? Think about it. Do we have to solve that? Think about it. I have given you hint in the previous question itself that you are changing the condition minus by negative by positive. Here positive by negative. That means the solution, the number line solution, that should exactly get reversed. Minus 1, minus 2. Somewhere here we will have minus 7. So in this case, if you simplify, you want to try, you can solve the inequality, but you are going to get this. Without solving itself, we can say, because the condition is getting exactly reverse. See, instead of positive by negative, it's becoming negative by positive. Instead of positive by negative, it's becoming negative by positive. So it's going to get reverse exactly. Yeah, arrows will be reversed. It was going towards left hand side. Now it will go towards right hand side. So the common values here, that is x more than, oh, what's wrong with my handwriting, more than -2. And in between these two cases, what is the conjunction we use? Or. For between these two cases, we use or as the conjunction. Inside the cases, we use and as the conjunction. So are you getting this? Yeah, it looks little lengthy when you look at the solution, because I'm explaining here. Otherwise, it's not very lengthy. Think about it. Any fraction to be negative, it has to be combination of negative by positive or positive by negative. You solve one side of the you solve one of the cases, and the other case solution has to be exactly reverse, and you see whether that exists, doesn't exist. Accordingly, you can come to the conclusion. So here we got conclusion, or so we can say x is less than -7 or x is more than -2. That's the answer. Do you want to see how do you write in form of bracket? In term of set, you will write x belongs to -∞ to -7 union or more than -2, right? So -2 to +∞. That's your answer, guys. That's your answer. This is your answer. Yes. So are you learning how to simplify the inequalities having denominator as fraction? Yeah, combination. Yeah, let me summarize this lecture for you. If it is more than 0, then you make the cases like positive by positive or negative by negative. If you get the expression less than 0, that means that's possible only when it's negative by positive or positive by negative. Yes. Okay, now yes, I have this question for you. Let me write this properly. So 1 upon x, here 1 upon x less than 1 upon 2. I want you to solve this and write the answer in comment box. Let me see how many of you are able to solve this. I will reply to your answer, so you will get to know that which answer is correct. Fine. So this is it in today's video. Before we go, let's see what are we going to discuss in the next lecture. So in next lecture is inequalities with quadratic expression. So quadratic inequalities. Fine. So my name is Shamanawat signing off. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye-bye.